Okay, all right. Present. Okay, so today, so we continue our class as usual. So actually, we're already in week 11. Okay, in January, so the last month of this semester. So inshallah, for the content of this course, we only left with two topics. Okay, so first one is this one is about economic of renewable energy, and the other one concerning the environment, the emissions, the gas emission, etc., due to the this renewable energy. Okay, so this week today we will see about this topic concerning economy of renewable energy. So actually, okay, first of all, okay, I'm not the an expert, okay, in economy or anything, okay, but I think you guys also, me and myself also, we learn a bit. We have to learn a bit about economy and the management in engineering. Okay, so I think during your bachelor degree program, you must have also learned a bit about account or something about economy. Okay, in this chapter, so in this course, we have this one topic concerning that we have to evaluate. Okay, those energy renewable energy technologies, evaluate them in terms of economy. Okay, and financial, of course. Okay, so I'm not going to because yeah, if we talk about economy, that it will be one whole course or even one whole program. Okay, so we're just going to apply those basic knowledge of economy in terms of renewable energy application. Okay. So maybe some of the theory, some of the concept you already you must have already learned before this, maybe in during your degree or during your college time. Okay. So there are, I think, three main notions or concept in this topic regarding this energy economics. But first, of course, some introduction to the energy economics. So we will see mainly some approach. Okay, there are two approach. Okay, so before that, okay, when evaluating the economic viability, why we need this energy economy, to evaluate this in terms of energy, in terms of economic viability of a renewable energy system. We must take into account these various factors, including capital cost, operation maintenance cost, fuel cost, right, the price of fuel, interest rates, etc. Okay, so we must take into account these factors. Okay, when we want to consider applying this renewable energy system technology. Okay, so there are two approach which are commonly used to evaluate the economic viability of renewable energy system, which is the first one is actually the first one that we're going to see is life cycle. We will see for life cycle first, LCC, life cycle cost analysis, and payback period analysis. Okay. And the other theory is about concerning time value of money. So when we talk about economy in renewable energy, we must also consider that money has time value. Okay, so for example, basic notion, time value of money. A dollar today is not the same as a dollar in a year. Okay, so what we have, example, if we have $10 or 10 ringgit now, is it the same as in we have the same 10 ringgit in 5 years to come? Okay, what will a 50,000 purchase you will make in 10 years be worth today? So those are the questions that maybe economy experts they will ask. Okay, whether what we the amount of money that we have now present, whether will be the value. Okay, the value will be the same in the next 5 years or in the next 10 years or not. Okay, So the convention that we use concerning the payment that occur at the end of the each period. Later on we will see the cash flow. Okay, the time cash flow is like the timeline of the product cost. Okay, so the convention that we use at the end of the payment is that we use this term end of each period, EOP. Okay, okay, there is one video here. Maybe we can just sorry, go full screen, share this tab. Okay, can you see this video? Wait, nampak tak video ni? Saya tak buka volume lagi. Nampak kan?
Nampak, Doktor.
Okay, saya play ya.
The time value of money is a concept that states a dollar today is always worth more than a dollar tomorrow. Suppose Steve wins $1 million in the lottery today. Before accepting his prize, Steve has to make a decision. He can receive the prize money now, or if he wants, he can collect the money in 1 year. Steve considers his options. If the money is taken today, he can deposit it in an interest-bearing savings account at the local bank that offers 5% interest per year. If he decides not to take the money today, he has to wait a full year with no money and no interest. Steve's not crazy, so he decides to take the $1 million sooner rather than later. When the money is withdrawn after a year, it has grown to $1,050,000. By taking the money early, Steve earned an extra $50,000. This is the time value of money as it applies to interest. $1 million is worth more today because of the possible interest that it earns over the 1 year's time.
Okay, just sharing the video. Okay, continue. Okay, so the notion, the concept behind this time value of money. Okay, so see, so there are, okay, so we use this term, okay, for to take into consideration this time value of money. So the first one is the principal cost, or sometimes we call it as capital cost. So we note as the initial sum, we note as P, principal, and we have also that we call interest, or in terms of percentage, okay, which means the productivity of money over time, money today versus money tomorrow. So normally we have this percentage of interest value, okay. So some definition, net present value. In order to calculate the payback period of a renewable energy system, we need to incorporate the time value of money. Okay, so because of inflation also, the value of money decrease over time. Also, money placed in a bank account or used to purchase bonds can grow with interest over time. Okay, so we see, saya nak skip dulu yang ni. Okay, this one. Okay, so a positive interest rate means that having $1 in 10 years is not as good as having $1 today. So the present value, okay, the capital cost, the initial cost that we have at the initial period, when we purchase, for example, the technology, the system, okay, so the present value will not be the same as the future value, maybe over 10 years or 5 years, okay, after the period of time that the apa tu system tu, kalau in this case we are talking about the renewable energy system, okay, dia punya period timeline dia, okay. So maybe after 10 years or 5 years, okay, the future value will not be the same as the initial capital, the initial value, capital cost when we bought the system, the technology. Okay. Okay, so for example, okay, so this is how we calculate and take into calculate the end of period, EOP just now. The value of the product, okay. Okay, the initial cost is P. Okay, so for example, we have N the system have a lifetime of n years. Okay, so the initial amount at initially 0 years. Okay, we have P. Okay, the initial cost, capital cost is at P value, and then the interest. Okay, the interest for the for each year. Okay, maybe 5% or 6%. Okay, normally this interest is accounted for annually. Okay, setiap tahun lah. Okay, dia punya amount tu. Okay, or sometimes monthly. Okay, then we divide by 12 lah. Okay, so the amount owed for next period after 1 tahun, after 1 year, after 2 years, 3 years, after a year. Okay, so we have to calculate, okay, recalculate it and to take into consideration the interest rate, the amount of interest rate given. Okay, okay, so macam ni lah. This is how we calculate the present value after n years, okay, of the lifetime of the project or the system, the technology. Okay, so we have this we use this formula. So the future F, okay, the future value F will be F equals to P, the present the initial cost, okay, times 1 plus I, the interest rate, and N is the years, depends on how many years the lifetime of the project or the system. Okay. So normally we will like to we draw a timeline, kind of like timeline cash flow, okay, of the amount of the project or the system, okay, commonly used to assess whether a residential energy efficient investment is economically sensible. So we kind of like a cash flow like this. Okay, a cash flow is a transfer of an amount from one entity to another at one point. Okay, so we have amount, okay, the initial capital cost and the annual cash flow, first year, second year, third year, fourth year. Okay, annual cash flow. So that each year there will be some amount of cash money, maksudnya gain, benefit or loss. Okay, yang berkait dengan concerning the project or the system. Okay, so ada yang masuk, ada yang keluar. Okay, so we so to calculate, to evaluate the end of period amount of the project. Okay, so we have to take into consideration annually, setiap tahun tu berapa banyak inflow and outflow lah, dia punya annual cash flow dia. Okay, due to the maintenance or due to operation or interest, etc. Okay, so basically kita buat cash flow of the project. Okay, so ini kita tengoklah berapa banyak income and dia punya penggunaan dia juga. Okay. Okay, so this one is example. Okay, so at present, at initial 0 year, okay, we have the capital cost. Okay, and then after end of year 1, okay, for example, we have the interest rate that we have to take into account, and then second year, third year until fourth year. So there ada incoming and outgoing cash flow. Okay, so setiap tahun tu sampai habis lah, until at the end of the period of the lifetime of the project or of the technology system. Okay. So ni example like this. Okay, so at first year ada 300 of inflow, benefit maybe, and then at third year ada cash flow, outgoing cash flow, and etc. D ni the same as I, 6% of interest rate. So the lifetime of the project is over 8 years. Okay, so and then we calculate, okay, at the how much the amount at the end of the lifetime of the project or the technology amount that an asset, okay, the project is estimated to be worth at the end of the its useful life. Maybe the project has a lifetime of 8 years. So by taking into consideration all this cash flow, ingoing and outgoing cash flow, and the interest rate at 6% yearly, annually. So we estimate at the end of the lifetime, here 8 years, how much is the amount of the asset or of the project is estimated to be worth at the end of its lifetime. Okay. Kita tengok example. Okay, one example. Okay, one example like this. Okay, so we will see example concerning renewable energy system lah. Okay, so a flat plate solar collector is to be installed in a facility for hot water production. Okay, the collector costs $10,000. $5,000. Saya silap tadi. Saya silap tadi. Sekejap. Silap tadi soalan rasanya ni. Silap. Betul. Okay, sorry. Okay, $10,000. Okay, you borrow 10,000. So the initial cost P, initial cost is $10,000. Okay, so you borrow, we borrow $10,000 from a bank. Okay, at an annual interest rate of 12%. So the interest rate is at 12%. Okay, compounded on a monthly basis. Okay, so we have to divide this 12% because on interest rate tu dikenakan setiap bulan. Dia dikenakan setiap bulan, lebih kurang macam itulah. Okay, so this 12%, 0.12, we have to divide by 12 lah. Monthly, so nak tahu monthly berapa banyak interest rate yang sebenar dikenakan setiap bulan. Sebenarnya dia tak lari banyak pun kalau kita kira annually or kita kira monthly, tapi dia adalah perbezaan tu sikit. Kalau kita pengiraan kita monthly or annually, dia ada slightly difference lah to the total amount tu. So kita ikutlah kalau kat sini in this example, the interest rate is compounded monthly, so we have to divide 12% to each month, so 12 months. So each month will have interest rate around 0.01. 0.01 means 1% lah. 1% for each month. Okay. You will have to pay back to the bank in 36 months. Okay. So imagine kita bayar balik kepada bank tu yang kita pinjam tu. 10,000 tadi kita pinjam, kena bayar balik dalam 36 months, which is 3 years lah. 3 years punya pinjaman. What is the amount of monthly payment? Okay, so monthly, setiap bulan, how much sebenarnya kita kena bayar lah. Okay, I think this one is very simple. And you guys also dah biasa kan beli kereta, maybe not install solar collector, but it's the same kind of the same method as when we make a loan with the bank to buy your car or your house kan. Okay, so simple calculation. So how much kat sini how much every month, monthly payment that we have to pay with this interest rate and payback tempoh untuk bayar balik adalah 3 tahun, 30 or 36 months. Okay, try to calculate that. Okay, so today we have to do a lot of example because this is about economy, so macam baik kena banyak kira-kira sikit lah kan, baru nampak sikit macam mana nak faham topik ni kan. So this is the first one, just calculate the amount of monthly payment due to this flat plate solar collector installation. Okay, so saya buka Okay. Okay, cara fikir dulu. Okay, okay, so if we draw a cash flow, the time, like a timeline tu, sini. Okay, this is the capital cost just now, P. Okay, 1 tahun. Okay, so here we are going to do this cash flow. We are going to calculate in terms monthly kan. So sebenarnya dia banyak lah, 1, 2, 3 kan, etc. until n. This is n months, not years kan, kita buat months lah, which is 36 lah kat sini. Okay. So this is time value, time in months. Banyaklah 3, 4, 5 ni until n. Okay. Okay. So we have another equation or terms. Okay. Yang kita panggil ke setiap for each of this month or year, this one is month, we have what we call U, the annual value or monthly value here. Okay, so ada U ni lah, yang kita, yang the payment yang kita kena bayar lah setiap tahun, setiap bulan tu. Okay. So, but in these questions just now, okay, dia tak ada tak ada information lain lah selain daripada interest rate. So we consider only ada interest rate lah, tak ada maintenance cost ke apa benda-benda yang lain tu kan, tak ada inflow outflow yang lain lah. So dia just ada interest rate yang kita kena kira lah untuk setiap bulan tu kan. Okay, so so dia ke bawah je lah arrow dia ni. Okay. So, okay, so U, so we have to find this U, right? For every month, monthly ni, apa kita kena bayar. Okay, so U is actually, we can use U, calculate in terms of the capital cost. Ada formula yang mudah sikit, okay. So the directly I, the interest rate just now, minus 1 plus I and the N. Okay, so this is the equation lah kan, form to calculate U, the each month or each year that we have to pay by taking into consideration the interest rate and the total month or the total years of the lifetime of the project tu lah. So since that the interest rate is compounded monthly, so and then kita pun dah bagi tadi 1%, so this I will become 0.01. Okay, so N ni pun kita letak 36 lah, kita tak letak 3. Kalau kita letak 3 kat sini, I ni kita consider 12% lah, 0.12. The answer maybe will be slightly different, tapi kita follow apa yang diberilah. So yang ni 0.0, okay, 10,000. The initial capital cost, so 0.01, 1% monthly, sorry, 3%. So yang ni 1.001 minus 36 lah, 36 months. Okay, ni point lah, bukan. Okay, so how much if you calculate this, so the monthly payment that we have to make to the bank, okay, so can be calculated this way. Okay, $10,000 multiplied with 0.01 monthly interest 1%, and for a period of 36 months, 36 bulan 3 tahun. Okay, so the total amount, kalau just tekan calculator tu, okay, total amount will be 300 bukan ini, $332. $332. Okay. So if we okay, this is the answer lah. Okay, we just want to compare, to analyze this amount. Okay. So if we multiply this $332 monthly paid, okay, for 36 months, berapa banyak sebenarnya kita bayar? Okay, kalau kita darab multiply 32 dengan 36, so kita ambil loan tu 3 tahun. So setiap bulan kita bayar 332. So sebenarnya berapa kita bayar after 36 months ataupun 3 years tu lah sebenarnya. So after 3 years, if we multiply ni, after 3 years we actually pay the bank around nearly 12,000 lah. Okay, 11,957. Okay, nearly 12,000. So macam tambah dalam 2,000 lah kan. Kalau 2,000 daripada 10,000 tu 20% lah. 20%. Nearly 20% extra lah yang interest. 20% of interest yang kita bayar. Due to the interest rate tu lah kan. Okay, so this is the additional value, $1,957, the additional value, that amount that we pay to the bank sebab kita pinjam tadi. Okay. Okay, back to the questions. Okay, so the total you have to pay back to the bank in 36 months. What is the amount of monthly payment? $332 monthly, and the total that we pay throughout the 36 months will be, if we follow the 36 months of the period of the loan tu, will be around 11,957, nearly 12,000. So dalam 20% plus, 20% plus, 2,000 tambahan lah kan yang kita bayar interest kepada bank. Okay. Okay. Okay, so that is so this is the a simple example, just considering the interest rate only. Okay, next. Okay, what if we know, okay, in general, an asset or a project, a technology, dia ada inflation, okay, impacts of inflation, inflasi. Okay, inflation is a general increase in the level of price in an economy. Equivalently, we may view inflation as a general decline in the value of the purchasing power of money. Kan decline lah, apa dalam bahasa Melayu, power of purchasing tu kan, kemampuan beli kan. Inflation is measured using price. Different products may have distinct escalation rates. Okay, so depends on the produk, benda tu lah, kan dia punya escalation rate tu berbeza-beza. Okay, so I will give you formula through example. Macam mana nak kira tu daripada example ni. Okay, so first, so this one we have to take into consideration the inflation lah, other than interest rate lah. So company A install a wind turbine that costs $15,000. Okay, so wind turbine $15,000. Okay. Calculations indicate that this wind turbine will save $3,000 per year from the electricity it saves for a period of 10 years. Okay, so by using this wind turbine, by installing this wind turbine, we will save, or company A will save 3,000 setahun electricity dia tu lah. Okay, kita assume dia boleh jimat $3,000 setahun electricity dia untuk selama 10 tahun, for a period of 10 years. Okay, and then the salvage value of the turbine at the end of 10 years period, the lifetime dia tu 10 years is 1,500. Okay, salvage value is like the income at the end of the lifetime period. Dia masuklah income at the end, inflow at the end of the turbine after 10 years period tu 1,500, estimated to 1,500. Okay, company B takes a different route and invests 15,000. Okay, so we have to compare, ada dua company ni. Company B takes a different route and invests $15,000 in a saving account. Taking the inflation taxation adjusted interest rate, okay, the term that we use for this interest rate, okay, means that in the initial interest rate, after taking into consideration inflation, tax, etc., it is adjusted. So dia jadi 5%, okay, for both application to be 5%. Okay, so mean this 5% is already included the inflation, tax, okay, dah kira dah. Determine which company will have more money after 10 years. Okay, so we have to compare between the choice between company A and company B. Okay, after 10 years, which company will make more money lah. Okay. Okay. Okay, so first tadi ni. Okay, so we have to calculate first. Okay, we know P the capital cost is 15,000 for both, $15,000, and then the 3,000 per year tu is the U just now, the annual, this time is annually annual value of the product, which is wind turbine. Okay, $3,000 annual that outflow cash tu. Okay, $3,000 per year, and then the interest rate tu 5% after taking into consideration inflation, tax semua tu. Okay, and the lifetime period is 10 years. Okay, so first we calculate first the future value F, future value estimated. Okay, future value of cost saving, maknanya after 10 years how much total saving that this system can make. Dengan install wind turbine ni setahun dapat save 3,000. Okay, after 10 years, how much total future value of cost saving after period of 10 years. Okay, so we can calculate this first. So okay. Okay, so here the same as P dengan U just now. So here we have another this one that links uh, U dengan F. So actually we just replace the P, the relation between PF tu. Okay, so 1 plus I N minus 1 over 1, okay, over I, this is I, the 5% tu. Okay, so F, the future value, U, 1 plus I power of N minus 1 over I. Okay, jadi just pusing-pusing balik formula tadi. Rearrange the formula. So U here, okay, here we want to calculate the future value of cost saving. Bukan future value of the total product tu yet. Okay. So the cost saving just now 3,000 due to the cost saving due to the electricity saving. Okay. So and this one 5%, so 1.05 power of 10 lah, sebab 10 years minus 1. Okay, divide by 0.05 lah, interest rate, taxation, inflation semua. Okay, so we have here the total future value of cost saving after 10 years. Okay, kira lah berapa dolar. Okay, total future value of cost saving. So kita ambil yang 3,000 tu, cost saving. And then nanti after we have this total future value of cost saving, this total ni kena tambah kepada add to the salvage value just now. Salvage value is the amount income at the end of the lifetime period tu, 10 tahun tu, 10 years. Okay, so this one is around 37,733. Okay, so the actual the actual future value ni at this one 37 ni to the salvage value given, which is apa tadi, at the end of 10 years period is 1,500. So plus 1,500, 37,733 plus 1,500. So this one will be around 40. Jadi berapa ni? 39,200 dollar future value. Okay, lah. Okay, dollar. Okay. Okay. And then also, so this is for company A, company A. So but if the if kalau this is by taking into consideration the 5% inflation interest rates now. Okay, if kita apa tu this saving amount 3,000 ni kita letak dalam bank, kita in the end future saving tu dapat dalam 39,000. Okay, but if we if we didn't deposited, tak letak dalam bank duit tu, saving kita after 10 years tu hanya 30,000 lah. 3,000 times 10 years, so 30,000 only, 30,000 only. Okay, this is company A. Company B, okay, for company B, 15,000 invested in the bank will okay, baca balik. Company B takes a different route and invest 15,000 in a saving account taken okay, determine which company. Okay, so for company B, like easier lah kita kira directly. Dia punya the initial capital cost tu P 15,000 and sini lah future value dia. Okay, so 15,000 1 plus 0.05 power of 10, ni 10. So we will have future value of 24,400. Okay, so ini 15,000 15,000 capital costs now. Okay. Okay, so is clear kat sini company A just now. Company A will have more money after 10 years kan. Tadi just now company A had 39,200 future value dia. Dia yang dia saving. Yang ni future value only 24,400. So company A will have tolaklah 39,200 minus 24,400. So company A will save around 14,800. Okay, more money available. Okay, at the end of the 10 years period. Okay, this by neglecting all the operating maintenance cost, apa semua expense, because it's not mentioned here kan. We only take into consideration the inflation interest rate. Okay, we didn't take into account those other operation or maintenance costs. Okay, so this one just to compare how much each of the company make, okay, by taking two different decision. Okay. Kita balik. Okay. That is tadi a simple calculation of a monthly payment or annually payment of a project or installation by considering the interest rate. And then the second one by taking into account also the inflation adjusted interest rate to the application, to the project. Okay, wind turbine. Okay, now another definition, a net present value. A simplified approach to calculating the net present value is to compare the present value of future fuel saving to the extra first cost of the more efficient device. Okay, thus NPV, net present value, total benefit in present time over minus total cost in present time. Okay, we will see this example also. NPV, net present value, total benefit minus total cost. Okay, or we can also use the notion benefit cost ratio. Benefit cost ratio is the ratio of the total benefit over total cost. NPV or benefit. Okay, example, wind turbine again. Okay, so wind turbine in here in Denmark, in Europe country. are getting larger, and some economies of scale are leading to improve economic for such system, particularly in high wind areas. Okay, so this is an example of in Denmark, average rated power of new wind turbine manufactured in Denmark. Okay, so the average energy productivity per site, okay, has doubled daripada from 600 kilowatt hour to 1.2 megawatt hour in the last 20 years. Okay, from 1982 to 2004. So the cost per kilowatt has dropped as the wind turbine have gotten larger. Okay, the capital cost have dropped from 1,400 per kilowatt in 1989 to approximately 800 per kilowatt. Okay, so normally as the technology go bigger, larger, the capital cost of the technology will slowly drop. Okay. An example cost analysis for okay, this is an example of analysis of a wind turbine 60 megawatt wind park in Canada. Okay, so what we're going to do next is the life cycle cost analysis. Okay, so this one different from the previous. Okay, previously we just take into consideration the interest, the inflation, the rate. We didn't take into account yet the cost of the production, the cost of the installation, the cost of the operation, etc. Okay, so with this life cycle cost analysis, we consider all these aspect, all these factors. Okay. So life cycle cost analysis is also noted as LCCA. Okay, is an economic tool. Okay, that we use to estimate the life cycle cost of the project, of the system, or for an installation. Okay. So this is the some of the like problem statement. Okay, why do we need to use this? Why we need to apply this life cycle cost analysis at CCA? So first one, project engineer wants to minimize capital cost as the only criteria. Maintenance engineering wants to minimize repair hours as the only criteria. So different stakeholder, okay, have different objective, different aim, of course, that they want to optimize for throughout the project kan. So project engineer they want to minimize the capital cost. Of course, maintenance engineer they want to minimize the repair hours. Okay, so we less time that we consider used to for maintenance kan. Production wants to maximize operation hours. Quality engineering nullify failures, buang failure. Accounting maximize project net present value. Shareholders want to increase stockholder wealth as the only criteria. So there's lots of conflict of interest, okay, between different stakeholder. Okay. So where are the biggest conflicts between stakeholders incentive concerning building? For example, for a building, okay, when we talk about the renewable energy applied to a building, so we have to consider maybe all these stakeholder, all these factors: material, owner, user, design engineer, HVAC, the heat ventilation supplier, contractor, etc. Okay, so for a building, there are several cost elements. Okay, initial cost, energy and water cost, operation, maintenance and repair cost, replacement cost, other cost tax, apa semua residual value. So dia ada terang kat sini. Okay, tak apa. Saya nanti boleh tengoklah dia punya tu. Those are the element cost for example of the building. When we want to evaluate the life cycle cost for a building, we have to take into consideration these factors. Okay, kita terus ke example. This one pun tak apalah. Okay, sebab ini lebih kepada window je, tak ada energy pun. Dia just need example of life cycle cost of a wooden windows. Okay, tak ada kaitan dengan energy. Okay, okay, system A, computing, okay, heating cooling system. Okay, for example, the first one, system A, using electric baseboard and window air conditioner. And second one is the usual heat pump HVAC lah. Okay, heating ventilation system. Okay, so we compare the life cycle cost of the system A and B throughout the periods of 15 years. Okay, so ada dia punya inflation apa semua, maintenance cost apa semua. Okay, we see example. Okay, ada dua lagi example. Okay, this one geothermal pula. Okay, we see the example of geothermal, a geothermal space heating system. Okay, a geothermal space heating system is to be installed for a commercial building to support natural gas heaters. Okay, so normal lah kita install geothermal space heating. The initial cost of the system is 50,000. Okay, so the capital cost tu P initial cost $50,000. It is estimated that the system will save the building $10,000 per year from the natural gas it save. Okay, so just now apa tu yang tadi yang 3,000 tu tak ingat tadi yang company tu tadi kan, dia wind turbine. Okay, the wind turbine will save the electricity for $3,000 per year. So here by using geothermal as the heat source for space heating of a commercial building, okay, we estimate that we can save $10,000 per year from the natural gas by using the conventional conventional, kalau yang sebelum tu lah biasa. Okay, it will take $2,000 per year to operate and maintain the geothermal system. Okay, however, so it's like this tau. Okay, later on, you try to draw a cash flow. Okay, you try to draw a cash flow. So tengok every year, each year tu how much whether you have inflow or outflow. Okay, so kalau so here the system is the building, so $10,000 per year save. So save is like a positive value lah, kita jimat kan. So dia inflow lah. Okay, however, it will take $2,000 per year to operate and maintain the geothermal system. Tapi however, each year kita akan guna 2,000 untuk maintenance operate. So outflow pula daripada cash flow tu kan, outflow dia adalah $2,000 each year. Okay, so the system will require a major cleaning after 6 years at a cost of 7,000. So this is once. Okay, sekali dalam tempoh 10 tahun ya tadi. Berapa total tadi? 12 tahun, 12 years. Okay. So during the period of the lifetime of the system geothermal, okay, ada satu kali which is after 6 tahun penggunaan. Okay, after 6 years of utilization, the system need a major cleaning. So the major cleaning ni sekali je, maknanya bukan 10 tahun. Okay, major cleaning tu 7,000. 7,000 cost untuk major cleaning tu 7,000. So kena adalah dalam cash flow tu at N6 dekat tahun ke-6 kena guna duit 7,000. Okay. The lifetime of the system is 12 years. Okay, total lifetime of the system is estimated to 12 years. After which the geothermal system will have a salvage value of $3,000. Okay, salvage value the income at the end of the lifetime of the project or of the system. The income tu maknanya inflow lah, positif lah. Okay. At the end of the lifetime of the system. Okay, determine the net present value of this project. Okay, take the inflation adjusted interest rate as 4%. Okay, the interest rate yang dah take into consideration inflation apa semua 4%. Kalau dia tak bagi if dia tak bagi tahu kata monthly or annually, we assume it is annual lah, yearly. 4% tu setiap tahun bukan month lah. Also calculate the benefit cost ratio. Okay. So you first calculate the net present value. So the formula for net present value just now, total benefit minus total cost. Okay. So we have to know how much is the total benefit and how much the total cost lah dulu. Okay. So first, try to draw the cash flow timeline. Cash flow timeline tu kan. So okay, initially we have 50,000. The initial cost is $50,000, and then throughout each year from year 1 until year 12, berapa banyak inflow outflow. Kalau actually dia bukan duit keluar masuk pun, cuma dia macam sistem tu kan, berapa banyak dia penggunaan duit dan berapa banyak interest yang dapat lah. Dan at the end of celebration value tu lah. Okay, try to sketch the timeline, the cash flow of the project tu dulu, baru kita boleh calculate net present value. Okay. Okay, so we want to calculate the net present value. Nama pun present value. It means that the benefit, the total benefit and the total cost have to be adjusted to the present value. Maknanya macam kata tadi 10,000. We save, there is benefit lah. We save $10,000, right? So but we have to take into consideration the time value of money, time value of money just now. So maybe that $10,000 per year will not be the same throughout the 12 years period of the lifetime of the system tu, geothermal system. So so we have to adjust it kan, calculate so kita tahu yang benefit yang sebenarnya after 12 years tu berapa. So tak boleh just ambil 10,000 tu directly lah. Sebab kita take into consideration consider the time value of money tu. Nanti kita compare dengan what if kita tak ambil kira time value of money tu. Kita tengok yang of course lah kita nak dalam example ni nak tunjuk dengan mengambil kira tu lagi bagus lah kan. Tapi kita compare lah, nanti kita tengok apa bezanya lah, berapa banyak bezanya kan dengan kalau kita ambil kira dengan tak ambil kira time value money tu lah. Sekejap ya, ambil air sekejap. Okay, I'll draw first the cash flow timeline though. Okay, so for example, we have the capital cost here P $50,000. Right. Okay, so and ni kan until time, so until 12 years lah. 12 years. Okay, the period of the lifetime of the project or the asset. Okay, so this time around we have inflow outflow, cost ataupun benefit. So sepatutnya dia ada naik ataupun turun lah. Buatlah satu-satu arrow ni sampai 12 lah. Sampai 12. Ni sampai 12. Okay. Oh, kejap. Yang tahun ke-6 tu nanti kena ada yang ni. Tahun ke-6, 1, 2, 3, 4, 5, 6. Okay. Okay. So, apa tadi? The initial cost $50,000. Sistem benefit dia, dia akan save building tu daripada natural gas 10,000 per year. So saving kita letak as positive value lah benefit lah, macam income ataupun benefit dia 10,000 setiap tahun 10,000 sampai sini pun 10,000. Okay, dia punya inflow lah sebab dia benefit ataupun income. Okay, and then it will take $2,000 per year to operate and maintain. So dia ada operation cost, maintenance setiap tahun 2,000. So yang ni cost, kita akan keluar duit. So 2,000 kat bawah ni lah. Sampailah 12 years. Throughout the lifetime, setiap tahun kena operation maintenance 2,000. Okay. And another information we have, the system will require a major cleaning after 6 years. Kena ada major cleaning after 6 years. Tahun ke-6. This one tahun ke-6 ada major cleaning. So 2,000 tu dah ada dah juga. 2,000 tu sebab setiap tahun kita tambah lagi, kena keluarkan lagi 7,000 untuk major cleaning. Okay, so dia kat atas ni adalah 10,000. Okay. What else? The lifetime of the system 12 years. Salvage value. Okay, salvage value income at the end of the lifetime 3,000. Salvage value macam income at the end of the lifetime $3,000. Okay, net present value. Okay, so we have and the interest rate, inflation adjusted interest rate 4%. Yearly lah, we assume yearly. Okay, so we have to calculate the total cost and the total benefit throughout the 12 years and adjusted, okay, to the adjusted ni macam mana, selaraskan dengan kepada present value tu. So means that we take into consideration the time value of money. So means that the throughout the period of time the value, nilai duit tu dia berbeza kan. Tahu, so kita ambil kira yang tu. Nanti kita bandingkan dengan kalau tak ambil kira. Kalau tak ambil kira nilai dia lain lah. Okay, so here our kita akan calculate beberapa different present value. Present value in terms of annual saving, present value in terms of operating maintenance, cleaning, betul kan? Okay, so saya guna P ni banyak kali. Okay, first P1, yang ni tak payah dah lah. P1 is $50,000. Okay, P2, I just name it as P2. P2 that we want to calculate is the present value of the annual saving. And it's only U tu kan? Okay. So U, just now the same formula as just now. U 1 minus 1 plus I power of minus N, 12 years over I. Okay, So this one P2 is the annual saving. Annual saving $10,000. 10,000. So U is 10,000. Letaklah 10,000. I is 4% and N is 12 years. So how much you get? Okay, P2 is the annual saving. 10,000. So calculate dalam 93,851. Okay, present value of annual saving. Okay, so means that kita tak ambil directly U. Kalau kita ambil directly U, it will be apa tu, U 10,000 multiply 12, 120,000 lah, 1,020 $100. But here, by considering the time value of money, the actual annual saving after 12 years is actually 93,000. Okay, and then P3, present value again, but this time for the operating and maintenance pula. Okay, so the same formula here, but U here is the operating maintenance 2,000 kan, 2,000 each year. So yang ni pun kita kira satu-satu, 2,000. So masuklah ni same thing masuk. Okay, 4%, 12 years. Okay, Margaret lewat sikit kan sekarang. So 7%. Okay, 7%. Okay, so this time P3 is the present value of the operation maintenance cost 2,000 tu kan. So dapat 18,000, 18,770. Okay, instead kalau kita tak take into consideration the value, the time value of money tu, 2,000 multiply 12 around 24,000 lah kan, instead 24,000. Okay, and then what else? We have major cleaning cost just now and the salvage value yang kita kena convert kepada present value juga. Okay, nak tulis kat mana tak muat. So next page. Okay, so I call it next one is P4 for the major cleaning cost. Okay, so since that the major cleaning is done only once throughout the lifetime, satu kali je, so kita tak payahlah guna yang U tu, sebab U tu kalau each year nak kena keluarkan duit ataupun benefit dapat. So ni sekali je, so kita gunalah macam future value macam biasa. Okay, 1 plus I power of N. Okay, so the future value will be the cost of the cleaning tu 7,000 sekali je kan. So bawah ni samalah, 1 plus 1.04 power of 12. Okay, power of 6, sorry. This sorry. Ni 6 sebab the cost of the cleaning tu dekat tahun ke-6. So tak payah, bukan 12 tahun ke-6. So at the 6th year, okay, so remember this one at the 6th year, lain sikit. So will be 5,532. Okay, so dia macam ni. The major cleaning will be done at the 6th year, after 6 years. Tahun ke-6 kan, after 6 tahun penggunaan, utilization, kita akan buat major cleaning yang akan cost, kita estimate cost major cleaning tu adalah 7,000. But that 7,000 of major cleaning in the next 6 years, in 2038, kan, 7,000. Tapi the amount at the present in this year 2032 will be 5,500 only. Okay, so this is P4. Another one, last one, P5, the salvage value. Okay, salvage value, same formula, just the F here is 3,000 salvage value. So sama bawah ni. Ni N is 12 so salvage value tu at the end of the lifetime, so you need 12 Okay, so this will be 1,874. Okay, so the present value of the salvage value tu in right now 2032 is 1,800 only, but in the next 12 years to come it could be it is estimated to be around $3,000. Okay, so now we can calculate the net present value, NPV total. So NPV kita dah calculate tu. So the total benefit minus expense or cost, or benefit we can also call it as income, benefit or income minus expenses as or cost dia lah, cost yang kita bayar tu expenses. Okay, so benefit, apa yang benefit? Okay, kalau if we look back at our cash flow, the benefit will be the one that we pay, the one that we save 10,000 each year ni, kita save kan from natural gas 10,000, this will be our benefit. Tapi kita dah calculate present value, it is accounted as 93,000. Okay, 93,851. So this is one of the benefit. Another benefit will be the salvage value. Okay, the salvage value 1874. Okay, so that those two are the only benefit lah from the cash flow. So that's why it's very important to draw first the cash flow, so kita tahu apa yang must inflow dengan outflow dia. So kat sini inflow dia yang saving natural gas tu and the salvage value. Okay, and the expense cost dia, expense yang kita guna adalah first kali capital cost lah. Don't forget about the capital cost, but capital cost is still the cost that we need to pay, the initial cost that we need to pay. So capital cost, expenses lagi the apa ni tadi 2,000 ni 2,000 operating maintenance each year 2,000 yang kita dah calculate kepada 18,000 present value, and the major cleaning 7,000. Okay, so ada tiga so the benefit is P2 plus P5. Expenses is the P1 plus P3 plus P4. Okay, so we have the net present value. Okay, will be 21,400. $21,400. Okay, try to calculate during our break time. Try to calculate what if we don't take we did not consider this time value of money, and we just added the benefit and subtracted minus the expenses kan. So berapa net value project ni, NPV dia? Dia tak panggil net NPV lah, dia panggil net value je lah. Kalau sebab NPV, net present value, which is by considering the time value of money. Tapi kalau kita tak consider time value of money tu, dia apa tu, value dia je lah. Okay, so what will be the net value of this project, geothermal space heating system ni, if we did not consider the time value of money, cash flow yang panjang-panjang, kita tak payah calculate dengan 12 years or 6 years just now. Just take it directly, the amount, and multiply with lifetime dia lah, 12 tahun apa semua tu, ataupun 6 tahun tadi yang ni, sekali bayar tu. Okay, so kira net value dia berapa, nanti tengok compare dengan yang ni lah, 21,400. Okay,
try tak kira interest ke doktor? Interest tu
tak ada. Tak kira interest. So tak adalah yang ni. Kita just darab dengan 12 kali, as if kita 10,000 tu kita dapat setiap tahun, so kali 12 jadi 120,000 kan. Nanti tambahlah yang lain-lain pun. Tak kira interest. Okay, during your break time try to calculate je, nanti kita tengok simple je calculation dia, lagi simple daripada yang ni lah. Tapi just compare berapa nilai beza dia banyak kan. Okay, so we take a break. 7.20 okay, nanti 7.45 atau 7.50 lah, 7.50. Okay. Okay, thank you. Jumpa sekejap lagi ya. Okay. Okay. Are you guys here? Back?
Yes, Doktor.
Okay. So Shiki, how much did you get? Did you calculate the net value without the interest? Did you try to calculate? Ada try
I
tak calculate?
stop.
Dapat
I
berapa?
stop until the net present. Not yet
Dapat-
the net value.
Cuba try net value. Lagi mudah sebenarnya net value tu tanpa interest rate. Just nak tahu beza banyak berapa.
Okay.
Means that the total benefit minus the total expense. Cuma kena, ada yang kena darab 12, ada yang tak payah darab 12 lah. Yang mana yang monthly tu, yearly tu kena darab 12 lah. Yang sekali saja tu macam cleaning tu tak payah lah. So berapa, how much total net value without considering the interest lah, time value of money. The others, you guys have here, apa ni, Safraiza, Anas, Ajin, ada ke? Are you guys here? Tak masuk lagi ke? Present. Okay, Ajin. Okay, Ajin, have you calculated the net value without the interest rate? Anas, berapa banyak net value?
Net value ialah 43,000.
42 kot.
42.
42. Mungkin ada silap calculate sikit. 42,000
Saya rasa sebab kalau macam doktor punya calculation ni, yang cleaning cost tu 7,000 Tapi dalam
Ya.
soalan tu 6,000.
Silap salin
Ha.
6,000 tak 7,000 ni? Kejap saya share balik. Ni 7 ni.
Oh, okay, 6 years. Okay, saya
6
salah.
years. 6 tahun, tahun ke-6 kan, 6 tahun. Tahun ke-6.
Okay.
7,000. Okay, so the net value tu saya tak tunjuk lah, direct je. So the total benefit without the interest rate tu means we have that 10,000 saving tu times 12 tahun plus 3,000 the salvage value, that is benefit also. Lepas tu so that is the total benefit lah. Total benefit minus the cost ataupun expenses, capital cost $50,000 plus the operation maintenance cost 2,000 yearly, so 2,000 darab 12 multiplied by 12 plus the major cleaning 7,000. So you have total benefit minus total expense $42,000. So that is the net value without considering the time value of money and the interest rate. Okay. So and then the benefit cost ratio. So benefit cost ratio is actually just the expense. The benefit of the ratio of the benefit over expense. So benefit bahagi expenses. Tadi berapa kira lah jumlah dia tu. So dapat benefit cost. So instead of tolak, kita bahagi dia tu je. Jumlah yang sama. So kalau benefit bahagi expenses, you get 1.29 or 1.3 directly. Okay, the ratio benefit cost. So this shows that if this ratio is higher than unity, means higher than 1, okay, means benefit is over expenses, benefit lagi banyak daripada expense. So thus kita kata this project geothermal space heating system tu boleh bagi green light lah. Kita kata macam kita estimate dia boleh bagi benefit lah, so kita bolehlah proceed with this project. Example. Okay. Okay.
Doktor
Ya.
boleh tanya?
Ya.
Untuk P4 tu, kalau yang cleaning tu,
P4 ni
katalah kalau dia every 4 years dia kena spend 7,000 kan. So dekat N tu jadi 8
okay. 4 years boleh tambah macam 7,000 1.04 kalau 4 years ni 4, tapi kena buat sebenarnya 4 kali lah ke sekali je 4 tahun keempat tu? Tahun keempat ke every 4 years you mean?
Every 4 years dia kena spend 7,000. So dalam 12 years tu
so 3 kali lah kan?
kena.
3 kali lah kan? Tahun keempat, tahun atau
last kali
last saya tak yalah, okay, 2 kali. So tambah je lah, masuk kat sini N ni jadi 4 and then 2 kali lah cost tu, so tambah lah 2 kali.
So kali dengan 2 je.
Kali dengan 2 lah. Kali semua ni dengan 2. Sini kena 4 lah. Sini 4 tu darat semua dengan darat semua. Yalah kali 2. 2 kali inilah cost tu. Kita kena bayar 2 kali. Dia patah balik dekat sini. Kita lukis ni kan. Kat sini 7,000. Sekarang ni tak adalah kan. Lepas tu tahun ke berapa? 8 kan. Tahun ke-8 kena tolak sekali lagi. Macam tu lah. So 2 kali kita kira lah kan. 2 kali ni.
Kira N tu ialah dia punya tahun ke berapa dia kena spend lah?
Ya.
Okay.
Okay. Okay, last part. The payback period Okay, payback period analysis. Okay, so it's very important to know how long it will take. Okay, so this payback period is the period how long it will take for the investment to pay for itself. Macam tu. Investment tu projek tu lah. Projek yang kita bayar tu kita kata macam worth it lah, berbaloi kan. Okay, this is called the payback period. So normally this payback period should be shorter than the life of the project. So for example, just now the life of the project of the geothermal system 12 years. So we expect payback period ni 10 tahun ke by the time 6 tahun ke kan, less then the lifetime lah, baru dia kita kata dia ada benefit lah, berbaloi lah kan, ada payback period tu. Okay. So how do we calculate this payback period, tempoh payback period ni? So actually from the same yang present value, annual, yearly U yang kita calculate tu. So kita ada N years tu kan. So kita nak tahu sekarang ni for example imagine that kita the N tu sekarang ni adalah tahun yang investment kita buat tu akan dapat pulangan tu kan. So kita nak tahu N tu. Okay, the time due to the time value of money. Okay, so back to the yang okay. Saya buka slide. Okay, tadi which one yang this one. Okay, this one, this equation, this expression, kita ada U dan kita ada N interest rate tu kan. So now the payback period tu, okay, discounted payback period kita akan calculate N ni. Okay, imagine that kita tahulah capital cost dengan the annual cash flow tu, U tu. Okay, so kita nak tahu N ni berapa. So just pusing-pusing ni punya itu. Okay, so we have this N, we call it discounted payback period, TPB, and years, so kita nak tahu. So jadi log lah bergaris. 1 minus P over U I. Okay, satu per atas log juga. So rearrange the equation just now. 1 plus I. Okay. 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 So this is the discounted payback period. So kita tengok example juga. Okay. And another one is the simple payback period. And this is investment over annual saving. Okay. Kita tengok dua-dua ni. Okay. Example. A renewable energy project is to be applied to a building which involves a solar photovoltaic system installation and a thermal wall. So we have two concept. Kita nak compare solar PV dengan thermal wall ni. Construction on the south side of the building. The building is heated by a natural gas boiler in winter and cooled by air conditioners in summer. Okay, normal lah guna gas boiler dengan air conditioner. It is estimated that the thermal wall will reduce the natural gas consumption by 7,500 term. Ini macam unit for macam thermal lah. Thermal unit heat dia tu. In winter, and the photovoltaic system will reduce the electricity consumption by 50,000 kilowatt hour in summer. The cost of the photovoltaic system and the thermal wall are 35,000 and 25,000 respectively. So yang solar PV tu 35,000, thermal wall 25,000, including the materials and labor. The unit cost of natural gas and electricity are 1.2 per thermal tu and 0.11 cents per kilowatt hour respectively. Cost, okay, unit cost of natural gas dengan electricity. Taking the interest rate to be 6%, determine the discounted and simple payback period for each application. Okay, neglect operating and maintenance cost and the salvage value in your analysis. Okay, so tak payah ambil kira yang tu. Okay, so kita first we calculate the annual saving in terms of electricity and the natural gas. Okay, by using the photovoltaic system. Okay, so photovoltaic system just now electricity saving 50,000 kilowatt hour. So kilowatt hour in summer, so per year lah. Summer tu sekali je setahun. So per year electricity saving 50,000 kilowatt hour. Dan we know that the cost of the unit cost of the electricity is 11 cents per kilowatt hour. So kita boleh dapat kat sini total electricity saving in per year. Okay. Yang this 50,000 kilowatt, this is per year. Yang ni pun per unit cost, this one also 11 cents per kilowatt hour. So kalau yang 50,000 ni darab dengan 11 ni, kita akan dapat 5,500 dollar electricity saving per year. Okay, saya tulis lah. So electricity saving, cost saving. Nanti kita kira yang natural gas pula. Okay. Saving, cost saving. Cost. So electricity tadi will reduce the electricity consumption. The trouble reduce the electricity and the photovoltaic system reduce the okay. The PV system tu akan reduce electricity consumption 50,000 kilowatt per year, kilowatt hour per year, kilowatt hour per year. So multiply dengan cost dia 11 sen kilowatt per kilowatt hour. Okay, so we have 5,500 electric cost saving per year. Okay, by using the PV system. And then for the therm wall. Okay, therm wall. Kita akan reduce natural gas. So natural gas saving pula. Natural gas saving. Natural gas. Cost saving. Cost saving. Okay. Natural gas tadi tu 7,500 thermal dia punya term tu macam kilowatt hour lah juga, tapi yang apa kita pakai untuk natural gas ni dia punya thermal tu, heat dia tu. Okay, this is term during winter, so winter is per year. Okay, and the unit cost is $1.2, RM1.20 per thermal tu. Okay, heat tu. Okay, so 7,500 multiply 1.2. So we have natural gas saving reduce $9,000 per year. Okay. So the total of 5,500 dengan 9,000 ni dapatlah 14,500. So total annual saving per year by using PV dengan therm wall. Total saving total saving 14,500 per year. Okay, by installing PV dengan therm wall. Okay. Okay, so now we want to calculate the payback period. Ada dua method tadi, discounted payback period dengan simple payback period. So for both installation PV dengan therm wall. Okay, ni total saving untuk both. Okay, masa sikit. 35. The cost of the photo. Okay. 5,500. Okay. Okay, now we want to use this formula, NDPB. DPP for PV dulu. Ni PV system. PV system, okay. The discounted payback period. So this one we take into consideration we consider the interest rate yang log tadi. So we have log 1 minus. So P is the for photovoltaic. P is the cost 35,000 given 35,000. The cost of the PV system. And the U annual saving. Okay, annual saving by using PV ni 5,500 lah just now. We calculate here 5,500 using PV 5,500. So 5,500 P over U. Okay, U here is the annual saving ni 5,500. And interest 6%, 0.06. Okay, minus 1 and over log again 1.06 there ya, 1.06. Okay, log. Okay, so berapa tahun? The discounted payback period. And another one in the simple payback period. Simple payback period, SPB. Simple payback period, we only take into account the investment or the capital cost, which is P, 35,000. The investment that we made to buy the cost of the PV system. Over the saving, annual saving 5,500 per year. Right. So this one is in dollar, this one is in dollar per year, so we have the answer in year lah, tahun. So this is the simple payback period by neglecting the time value of money. Okay, so this one and this one. So the discounted payback period just now or by considering the interest rate tu, kita dapat 8.25. Ya. Kalau 0.25 je ni dalam 4 bulan lah. 4 bulan. Bukan, 3 bulan, 3 bulan. 8 years and 3 months. Kan? 3 kali 4, 12. Okay. 8 years and 3 months. Kalau by taking time value of money tu means after 8 tahun, lebih sikit 8 tahun 3 bulan baru dapat payback period lah. Investment tu berbaloi lah worth will pay for itself kita macam tu. Investment yang kita beli 35,000 kita beli PV tu berbaloi lah, kita kata dapat balik payback period 8 tahun 3 bulan. Dengan ambil kira consider the time value of money. Okay, but what if kita tak consider the decline in the value of the money tu, kita just investment over the annual saving tu lagi rendah lah, sebab kita tak ambil kira the decline of the value money tu. So 6 tahun je dah boleh dapat, ni ideal lah kan, kalau duit tu tak decline kan, tapi sebenarnya tak lah. So 6 tahun lebih, 6 tahun dalam hampir 6 tahun setengah lah, tapi tak sampai. Okay. 6 tahun, 6 years. Okay, this is for the PV. For throne wall, same method. So saya tak tulis equation throne wall same method. So discounted payback period for throne wall. Cost dia tadi cost dia $25,000, P dia $25,000, and the annual saving dia 9,000 per year, annual saving of the natural gas. The same formula, 6% etc. So we have DPB 3.13 year. 3 tahun 0.13 kira lah 3 tahun lebih lah, 3 tahun plus, and yang simple payback period just about 2.78 year. So nearly around 3 years lah dia punya payback period untuk throne wall. So throne wall lebih cepat lah orang kata, lebih cepat dia punya, kita dapat rasa the worth lah. The photovoltaic system has a longer payback period than the throne wall. Okay, so the simple payback period underestimate the actual payback period. So discounted yang DPB ni, this is the actual, yang ni dia ideal case. Okay, so the simple payback period underestimate the actual payback period by about 23 months untuk PV system, for PV system, and about 4 months, okay, beza ni, about 4 months for the throne wall. So dia underestimate lah, yang simple ni dia underestimate. So sebenarnya adalah 3 tahun dan sebenarnya adalah 8 tahun baru kita dapat payback period tu bila kita install the system lah. Okay? Okay, everyone? Okay, tu saja. Okay, I just for this chapter I just take yang mana important theory lah yang we need to apply when consider this renewable energy system. Okay, so before we finish, so I have one last assignment for you. InsyaAllah, this will be your last task lah. Okay. Ni. Buka slides. Okay, this last task it was supposed to be a project lah kan, kind of a project. So dia percentage dia higher lah daripada yang sebelum-sebelum ni punya task, rasanya 10%, 20% kan. This one will be 30 kot saya tulis hari tu ya. Saya tengok, saya check balik hari tu saya Saya dah cakap berapa. Tak. Sini. Chapter 1, sorry. Chapter 1, introduction. So assignment 20% dah buat dah, 10, quiz 10%. So this one is actually 30%. So highest lah yang ni. I mean, final exam lah. Final exam 40. Okay. Okay. Yang ni Okay, so actually initially if we were to have face-to-face class, actually patutnya ada macam this course should have like 6 hours of 2 weeks of macam project lah, experiment, task, hands-on. Okay, and then lepas tu kalau if we, tak dapat nak face to face tu, ingat nak buat macam any simulation modeling kan, tapi itulah software pun tak sempat nak beli, tak boleh jadi. Tapi itulah, this is my calangan, okay, idea, suggestion, okay, renewable energy technology for building application. So okay, ni. Okay, actually okay, what I want you to do actually is sebaiknya adalah yang the second assignment when you propose the renewable energy system kan, untuk setiap type of building kan. Ada yang buat untuk high rise building, untuk rural building, residential building kan. Ideally you guys apply lah apa yang the idea yang you guys dah propose dalam second assignment tu. Okay, if possible. Okay, so macam ni, in this project, each student will develop a renewable energy technology system, because you have done the literature review, you have done a little bit of the study of the background. So ideally, sebaiknya apply lah apa yang you dah propose, yang you dah baca, you dah study tu kan. Okay, tapi kalau tak possible, boleh je nak tukar yang lain, konsep lain. Tapi tak tahu lah, I think lebih mudah lah sebab you dah propose benda tu kan. Okay, and evaluate the performance of the system and compare it with the current technology. Okay, so basically simple je. These three main keyword, develop. If you already have the idea, you want to continue the idea that you have proposed in the previous assignment, you can do that. Okay, you develop the renewable energy technology system model for the building application, high-rise building or residential building, etc. that you have. Kan nak guna geothermal ke nak guna hydropower hari tu kan, ada yang propose hydropower, ada guna propose wind or solar, etc. kan. Okay, so propose that, sketch elok-elok lah dia punya macam mana dia punya sistem tu yang you propose tu. Lepas tu evaluate the performance of the system tu, estimate berapa banyak dia penggunaan tenaga dia, performance dia kan, efficiency semua tu, and compare with the current technology. Okay, nanti sekejap lagi saya cakap example lah, task one ni. Okay, and then compare dengan apa yang sedia ada lah, yang the current present technology. Okay, so okay, there are I propose these 3 types of method. Okay, ada 3 method yang saya terfikir propose untuk ganti apa tu yang tak dapat buat eksperimen hands on lah. Okay, ada 3 cara lah yang saya propose, tapi not limited to this method lah kan. Boleh, kalau ada idea lain, cara lain untuk method dari sudut method dari sudut method tu, kalau ada cadangan lain boleh cadangkan, boleh suggest, you can suggest. Okay, but these are the 3 proposed method lah yang saya cadangkan. Okay, first kali, ideally if you are already familiar with any energy modeling simulation software yang free ke, ataupun ada yang dah ada yang berbayar ke, tak tahu lah kalau kat tempat kerja ke apa ke, ataupun ada yang free ni. Contoh example yang saya pun tak ada untuk semua ni. Ada yang Energy Plus saya pernah tahu, yang lain-lain ni saya pun tak pernah guna, but I know they exist lah kan. Okay, so these are the example of energy modeling software. Maksud dia model lah sistem tu. Kalau nak buat heat pump ke, nak buat solar ke apa ke, dia dah ada dia punya model tu, and then kita just sambung-sambung dia, and then kita boleh run lah simulation and calculate lah performance apa semua, etc. Okay, so these are the example. Ada saya bagi link ni kalau nak tengok. Cumanya kena kalau tak biasa guna, tak pernah guna, tak pernah tahu, mungkin kena study sikit lah macam mana cara nak guna dia kan. Biasanya dia kalau modeling simulation software ni dia just simple je, dia dah ada punya model-model komponen tu, kita sambung-sambung je. Macam contoh S10 Plus ni pun student bachelor saya pernah guna, cuma ni saya tak jumpa itu yang dia guna. Dia guna dia download yang crack lah. So dia cari sendiri sebenarnya. Okay, yang saya bagi link-link ni yang memang open lah, open maknanya yang basic software tu open untuk download lah. Okay, so kalau nak guna energy model software ni pun boleh, tapi cubanya mungkin kena belajar sikit lah macam mana nak guna software-software tu kan, dengan masa yang ada lah ni lah kan, tinggal lagi sebulan lah nak habis semester ni. So ini cara yang pertama, first suggestion, dan sebaiknya macam ni lah, nampaklah sikit macam bila you buat modeling software, modeling ni nampaklah dia macam you sambung macam mana pump dengan nanti burner dia, evaporator semua, nampaklah how the system operates kan. Okay, but if you cannot use this modeling software ni, tak boleh download ataupun tak reti nak guna ke kan, tak sempat nak study ke apa ke, another one is simple lah, guna programming software. Okay, MATLAB, CLab ataupun any apa lagi, Python kan ada kan. Ni kira numerical modeling lah. If you use this second method, means that it requires a numerical modeling of the thermodynamic cycle. So maknanya kalau macam if you buat heat pump, you kena tahulah sikit dia punya equation heat pump tu macam mana apa semua kan, sebab nanti you nak key in dalam contoh MATLAB tu kan, Python tu kan, you kena buat macam coding sikit, tapi I think tak complicated sangat coding, sebab there are some parameters that maybe you know or you can assume, and then you just mungkin kena buat loop ke kan untuk validate you punya assumption tu lah kan. So kena ada simple programming sikit lah maybe kan dalam calculation cycle you tu, numerical modeling you tu, numerical modeling tu dia ada mathematical equation. So mungkin ada certain value yang you kena assume. So and then in order to macam secure you punya value yang you assume tu, you kena ada loop lah kan, untuk kurangkan error kan yang the value yang you assume. Ni I think you know lah, macam computer programming sikit, tapi tak complicated sangat lah. So this is the second one. Maknanya you kalau you guna programming software ni, you buat numerical modeling lah. You do the numerical modeling based on the thermodynamic cycle tu lah, equation thermodynamic tu kena cari, kena ada lah the equation thermodynamic tu. And then last option, ni saya kurang prefer lah kan, sebab dia macam dia just guna Excel je, but this is the at least you try to calculate something lah kan. Kalau the last option is by using just Excel, tapi if you do Excel, you still need the mathematical equation apa semua tu kan, because you nak kira performance, you nak kira energy, nak kira heat ke apa ke kan. You still kena ada equation tu lah nak key in dalam Excel tu, dan you need parameters lah, initial parameter nak key in lah, nak guna, nak calculate tu kan, nak assume efficiency dia, kena assume dia punya temperature ke apa ke, kena ada reference lah. So boleh juga yang ni, tapi nanti kalau buat guna Excel ni nanti keluarkanlah graf-graf dia lah kan, nampak cantik sikit lah to present your results kan. Kalau nak guna Excel saja. Okay, and then so task 1, develop the schematic diagram of the renewable energy technology system kan. Tadi kan you dah propose you punya renewable energy system tu, so for example you nak buat hydropower untuk rural house, tak kampung-kampung kan, and list out the energy performance equation of the system. Okay, so whatever it is, kalau you guna modeling software pun you still kena ada equation lah, how you calculate the performance. Basically bila kata energy performance ni, how do you calculate the whole system efficiency, power generate, and maybe some total heat ataupun fuel input tu berapa banyak heat heat require kan. So in the end you akan dapat calculate the system efficiency. Okay, how to calculate the power produced over overall system efficiency. Okay, use either one of the application yang tadi saya suggest. Okay, untuk buat ni. And then task number 2, simulate the energy system. Kalau you buat yang modeling tu, you simulate lah. Kalau tak, you just you masukkan you choose the correct mathematical model equation and key in mathematical model tu, key in dia punya parameter and calculate lah. Calculate, lepas tu nanti you compare dengan the present current conventional system yang ada. Tapi kena cite lah reference yang you compare tu lah. Okay, the baseline yang you ambil tu. Okay, example, you are trying to develop a HVAC system, heating, ventilation, air conditioning system for a residential building using solar energy as its source. For example, untuk rumah, kawasan rumah, you nak buat HVAC system tapi guna solar energy, tapi solar tu pun ada macam-macam size kan, so nanti depends lah apa yang you nak propose. So you have to compare your result with the conventional system that use HVAC with non-renewable source, maybe using boiler, natural gas kan, kat rumah tu asalnya lah conventional, dia guna natural gas biasa. So just ambil je value yang conventional tu, yang baseline tu berapa, nanti compare lah dengan kalau you guna solar energy dengan cost, tak payah cost, size tu kan, area, berapa banyak heat daripada solar energy tu dapat hasilkan, compare dengan kalau yang biasa berapa. Itu je lah, compare and examine the energy performance of your system. Lepas tu analyse lah, nanti buat dalam report tu sikit, keluarkanlah kalau boleh dalam bentuk grafik lah kan, you punya results tu, I mean throughout the, for example, if you change the heat source tu, mungkin ada beza temperature yang berbeza kan, from for certain range of temperature kan. So ada limitation dia lah, heat source punya temperature for example, and throughout the temperature tu berapa banyak power yang you dapat hasilkan kan. So keluarkanlah result-result tu and analyse lah kenapa you dapat sini, apa semua tu, compare apa semua, macam tu biasalah. Okay, so the analysis and discussion of the results, and lastly, finally, present lah report tu, hantar report of the ni lah, project ni hantar and kita present lah macam biasa sebab kita tak ramai, so boleh lah buat presentation ni. At the end week 14 lah, last minggu terakhir semester, sebab ni dah minggu ke-11. Minggu 11, minggu depan ada satu lagi chapter concerning the environment emissions, gas emission. Lepas tu another week tu saya bagi masa untuk, saya kosongkan, bagi masa untuk siapkan projek ni, tapi dah boleh start daripada sekarang. So nanti week terakhir ni, at the end of this month, kita you guys submit and present lah, share your findings lah. Okay, so 26, this will be your deadline lah, 26 January. Okay, any question? Dia macam open sikit, saya tak macam tak apa kata, macam bagi arahan lah kan, spesifik kena buat macam ni, kena buat macam ni. Saya open kepada satu yang konsep tadi tu, teknologi tu saya open, walaupun saya suggest kalau boleh you continue je lah yang you dah propose hari tu kan. Kalau boleh continue, kalau rasa macam yang hari tu bagi tu macam tak sesuai lah pula, nak tukar yang lain, boleh je tukar. Cumanya lebih mudah lah kalau dah, sebab you dah study apa yang you propose hari tu, so you boleh save time lah dari sudut bacaan tu kan, nak buat literature review tu. Okay, lepas tu yang lain-lain tu saya open lah, apa you nak, how you do it, how you going to evaluate the system apa semua tu. Okay.
Doktor,
Ya.
boleh tanya?
Ya.
Kalau yang compare dengan current technology tu, kalau macam office dekat Malaysia ni kan, dia pakai elektrik macam biasa TNB supply tu, compare dengan penggunaan dia je lah.
Okay, saya suggest maybe you macam tu lah tadi yang saya bagi contoh tu, maybe you tak payahlah compare semua benda. Contoh macam tadi kalau you nak buat nak propose untuk HVAC aircon je ke, you nak buat aircon, you tak maknanya you just compare dengan penggunaan aircon saja dekat bangunan tu. You tak payahlah ambil yang lain-lain tu, guna komputer elektrik apa semua tu. Just focus on one, compare dari sudut satu benda je, satu penggunaan utilization je. Boleh ke? Macam tu. Faham tak?
Tapi macam mana nak dapat?
Macam mana?
Macam mana nak dapat data aircon, penggunaan aircon? Biasa kalau macam office kan, yang saya boleh nampak lah dia punya penggunaan elektrik every month dia compare dengan itu
The whole office building tu campur dengan boleh juga, cuma dia tu macam yelah sebab nanti sebab kalau you propose untuk satu part je, kalau you propose macam nak guna solar ataupun wind tu untuk the whole electricity of the building tu bolehlah juga, cumanya takut macam banyaklah pula you nak buat nanti kerja yang you nak kena ni. Tak boleh, cuba dulu macam ni kalau kalau you propose memang totally the whole building tu nak terus tukar ke bukan HVAC, bukan aircon je ke, the whole office building tu nak tukar kepada renewable, guna wind dengan solar ke contohnya kan. Boleh lah nanti you compare dengan the whole yang TNB tu punya data tu kan.
Cuma yang saya propose hari tu dia hybrid. Dia kalau dia pakai solar dengan wind, kalau tak cukup dia akan ambil daripada TNB jugalah. Tapi the whole building lah. Kalau macam aircon ni, macam mana saya biasanya lah macam mana nak tahu dia punya penggunaan aircon saja. Itu yang saya rasa macam
susah nak dapat data tu Kalau daripada kalau TNB spesifik tak pasti, tapi kalau macam sebab kalau macam publish paper tu kadang-kadang dia ada je macam data untuk dia buat untuk certain sistem tu saja. Tapi tak apalah kalau tak dapat jumpa yang yang you propose dulu you punya model, you buat apa semua solar wind ke apa tu tadi. Tak apa, nanti kita yang data yang you ada tu katalah you ada data dulu tapi untuk the whole office building kan. Tak apa, kita tengok je lah data dari sudut macam kita faham lah yang you buat tu hanya untuk certain part, yang ni untuk the whole. Kita tak compare one to one punya compare directly calculation berapa banyak macam payback ke apa kan, berbaloi ke tak macam tu kan. Tapi at least kita tengok dari sudut mungkin percentage dia, how much dia punya benefit daripada the whole electricity utilization of the office building tu kan. Berapa banyak yang renewable energy ni boleh membantu. Contoh kalau macam office building, saya tak tahu lah dalam rate dia katalah dia punya penggunaan dia example berapa 15 megawatt ke kan contoh tapi yang you punya ni untuk just yang part yang solar dengan wind ni dia dapat hasilkan maybe 1 megawatt. So means sistem renewable energy yang you propose ni can replace satu daripada 15 percentage tu lah kan dapat membantu just that portion lah of the office building. Jadi bila saya kata compare ni, it doesn't mean that macam just nak tunjuk yang directly yang renewable energy ni the only solution ataupun always better lah. Bila tengok berapa banyak dia boleh membantu kan untuk improve sistem dekat building tu lah. Tak adalah nak calculate macam one by one calculate, tapi kita analyse benda tu. Tak apalah, cuba dulu. Kan.
Doktor,
Ya.
kita kena compare juga ke the installation cost, macam kalau kata electrical yang sedia ada ni dia just wiring semua kan, tapi kalau kata guna solar termasuklah installation of the solar panel lagi, jadi kena masuk ke cost tu?
Cost tak payahlah. Cuma kat sini you guys kena calculate yang performance power efficiency tu saja. Cost tak payah calculate, tapi you boleh reasoning dalam you punya report analisa tu. You boleh lah reason cakaplah kalau guna ni akan tambah cost apa semua dari sudut sekian-sekian maintenance ke operation ke installation ke apa-apa. Tapi you tak payah kira one by one lah, cost tu tak termasuk dalam ni lah. You just macam argument you lah.
Kalau kita kata just that one is on the side of the disadvantage je lah kan? Okay.
Okay. Aijin dengan Safraiza, any question?
Outcome dia power lah doktor, kita compare power dia.
Ya, Azan certificate performance. So biasanya bila performance ni kita tengok the system efficiency, power yang dia dapat hasilkan, dan maybe reduce the
Cost.
Cost sebab kita tahu dah tadi yang Syikin tanya kita tak ada value exact kan. Dengan maybe heat input ada certain yang macam guna fuel ke apa ke kan, berapa banyak fuel yang perlu dibakar tu kan, instead kalau guna renewable energy ni mungkin kita boleh save fuel tu, heat input lah, heat source tu.
Okay.
Thermal system dia lah, thermodynamic sikit lah.
Doktor, I have a question.
Task tu antara satu atau dua je? Ataupun kena buat dua-dua?
Yang task ni memang buat semua, task 1, 2, 3.
Oh,
1, 2,
okay.
3 kan, ni macam step-step dia lah. Step ni buat ni. Yang tadi yang method ni yang saya bagi pilih ni, 1, 2, 3 ni pilih satu.
Oh, okay. Alright.
Cara macam mana you nak evaluate the performance of the system tu, saya suggest 3 ni lah. Saya tak nampak lagi cara yang lain. I mean kalau dari sudut macam online lah. Kalau nak buat
macam saya tak pernah guna pun semua software ni. Jadi kalau pendapat doktor, yang mana paling senang nak faham lah untuk kita belajar dulu lepas tu baru nak guna?
Saya pun tak ada guna semua, tapi Energy Plus saya pernah lah. Aspen Plus, Energy Plus dengan Aspen Plus tu student saya pernah guna, so saya tahu sikit-sikit. Dua itulah yang saya pernah macam kind of tengok lah sikit macam tu. Yang lain tu saya tak pernah try juga lagi.
Okay.
Doctor?
Yeah.
So I have a question. So instead of focus on the whole building, can focus on some part of the building like the server room or the emergency room, something like that?
Okay, emergency ni apa? Hospital sebab you
for the hospital. So sometimes blackout dia memang ada generator under macam petrol or diesel, but instead of using the fuel, maybe can replace with the renewable energy, right? So is it okay if focus on certain part of the building?
Okay, boleh. Maknanya you you macam satu department kat hospital tu je ke kan? Satu floor or boleh juga.
Maybe hospital or macam control
satu
server
function
room.
lah, one function dia je lah.
Yes, doctor. Maybe for the cooling also, for cooling for the server room also, something like that.
Okay, boleh. Okay. Just that you explain lah you punya case study tu. Means you case study you punya limit scope tu. Your scope is only about this lah.
Okay, doctor. Thank you.
Okay. Any more question? Let's stop recording ni.